Let's explore the heap, a crucial memory region in C programming. The heap is a region of memory separate from the stack, used for dynamic memory allocation during program execution. Let's understand what the heap is and why it exists. The heap is a memory region where you can allocate memory at runtime when you don't know the size at compile time. Unlike the stack, which automatically manages memory, heap memory persists until you explicitly free it. The stack has a fixed size with automatic management, while the heap grows dynamically and requires manual management. C provides several functions to work with heap memory. The malloc function allocates a block of memory but doesn't initialize it. You call malloc with the size in bytes you need, and it returns a pointer to the allocated memory. The calloc function allocates memory and initializes all bytes to 0. You call calloc with the number of elements and size of each element. The free function releases memory back to the heap when you're done using it. You call free with the pointer to release that memory block. Let's see how to use heap memory with a practical example. Here we allocate space for 5 integers on the heap. The pointer PTR now points to the first element of this array. We allocate enough memory for 5 integers using malloc and the size of operator. Once allocated, you can use this memory just like a regular array, accessing elements with index notation. When you're finished with the memory, you must call free to prevent memory leaks. One of the biggest dangers with heap memory is memory leaks. A memory leak occurs when you allocate heap memory but forget to free it, causing your program to consume more and more memory over time. Memory leaks happen when you lose track of a pointer to allocated memory without calling free first. If your program repeatedly leaks memory, it will eventually exhaust available memory and crash. Let's look at some common operations you'll perform with heap memory. The typical heap workflow is: allocate memory with malloc or calloc, use the memory for your data, then free it when done. The reloc function lets you resize an existing heap allocation if you need more or less space. You call reloc with the old pointer and new size, and it returns a pointer to the resize block. Understanding when to use heap versus stack is crucial. Stack is faster and automatically managed but has fixed size, while heap is slower and needs manual management but offers dynamic sizing. Use the stack for small amounts of data that only exist within a function scope. Use the heap when you need large amounts of memory or data that must persist beyond a function's lifetime. Let's review the key points about heap memory in C. The heap gives you the flexibility to allocate memory dynamically during program execution. Use malloc for uninitialized memory, calloc for zeroed memory, and reloc to resize allocations. Always remember to free every allocation to prevent memory leaks that can crash your program. While heap memory requires careful manual management, it provides the flexibility needed for complex programs.